Hey, my name is Milan, and in today's video I'll show you how to securely store and use secret values inside of your .NET applications. Examples of these secret values include connection strings, API keys, or various credentials. We're going to use a service called AWS Secrets Manager to facilitate creating and using these secret values in a secure way. I also want to say a huge thank you to AWS for sponsoring this video and helping me bring AWS closer to the .NET community. Now let's dive into AWS Secrets Manager. The most important feature of AWS Secrets Manager is allowing us to securely store and use our application secrets. Now it also comes with built-in encryption, secure access policies using IAM, and a very easy to use SDK for .NET applications. But let's not get ahead of ourselves and let's discuss what we're going to cover in this video. So our agenda for today is going to be explaining why do we need AWS Secrets Manager and why can't we do something similar using just our application settings, which are a popular way to store configuration values in a .NET application. We're also going to talk about encryption, IAM, KMS, which is short for Key Management Service. We're also going to discuss the concept of secrets rotation, which Secrets Manager does give you. We're going to talk about the pricing model of this service, and then I'm going to show you how to use Secrets Manager from a .NET application. So let's start with the obvious question, and that is why do we need AWS Secrets Manager? This is one of the more popular secret management services out there, but it's not the only one. There's also Azure Key Vault or HashiCorp Vault, which serve a similar purpose, but they won't be the focus of this video as we are only going to talk about AWS Secrets Manager. Let's try to explain this with a practical example. I have a simple web application that wants to interact with GitHub. We could be managing user profiles or repositories. It doesn't really matter. What's important is that our application wants to talk with GitHub, and GitHub exposes an API which allows external services to build integrations. To be able to call the GitHub API and obtain a response, we first need to obtain an access token. You can obtain an access token through the GitHub user interface, and you also have the ability to fine-tune what are the permissions for a particular token, so you can implement very fine-grained access control for each access token. Now, an access token is going to look something like this. Of course, this is a dummy token value, but we're going to be using a real access token later when I show you our GitHub API integration. The problem that we are trying to solve is that we need a way to securely store and use this access token from our application, and so that we can talk to the GitHub API. A few options that we could consider for storing this access token is adding it as an environment variable. We can then reference this environment variable from our application and use it to interact with the GitHub API. Another popular approach for .NET applications at least is using application settings to provide configuration values, but I don't recommend that you use this because it's going to be part of your source control. And one thing that poses a significant security risk is leaking your application secrets into source control. So that's why I recommend that you avoid application settings and instead you can use the user secrets concept. User secrets live outside of the context of your application, but you have a way to reference them from your code and you can use them on your local machine. So this is a great option for your local development. But in a production environment, we want to use something more robust, and this is where AWS Secrets Manager comes in. So let's take a look at our example and let's introduce AWS Secrets Manager into our ecosystem. So we have our application, the same as before, that wants to talk to the GitHub API. In order to do that, it needs to provide an access token, and this time we're going to be using the AWS Secrets Manager service. Our application at runtime is going to reach out to Secrets Manager and is basically going to send a GET request to fetch a secret based on the secret ID. And the secret ID is just a unique name that we assigned to a secret value. Secrets Manager is going to give us back the secret, if it exists, and we're going to use the secret value as the access token that we provide in our request that we send to the GitHub API. So this slightly changes our initial flow. We now need to send an additional request to the AWS Secrets Manager service to obtain the secret value before we can communicate with our external API. But why is using AWS Secrets Manager or any other secret management service better than using something simple like environment variables? I think this is an excellent question, so let's take a look at the big picture of using AWS Secrets Manager and how it helps us build a more secure application. So Secrets Manager is a managed AWS service for securely storing application secrets. I mentioned at the start that these could be API keys, database connection strings, various credentials, and so on. The key here is that this is a managed service, so AWS takes care of a lot of things. For example, example, Secrets Manager is a highly available service, so you can always count on your secrets being available to your applications. It also takes care of encrypting your application secrets both at rest and in transit, and it uses the key management service, which is another AWS service, and it allows us to encrypt our application secrets that we store inside of Secrets Manager. Another core feature of the Secrets Manager service is that it's tightly coupled with the IAM service, which stands for Identity and Access Management. IAM allows us to implement fine-grained access policies for our application secrets, so we can control which services in AWS have access to our secrets, and this is going to help us build more secure applications. And last but not least is that Secrets Manager also supports rotation, allowing us to control secret lifetime. There are a few AWS services that implement secret rotation automatically, but you can also configure rotation for your individual secret values. I'm going to show you how to achieve this when we go into the AWS console. Let's also discuss the pricing aspect before we go into the fun part. And AWS Secrets Manager comes with a 30-day free trial. After that, you have to pay 40 cents per secret per month and 5 cents per every 10,000 API calls. Now, this might seem significant, but considering what you get with AWS Secrets Manager, it's well worth the price. Another thing to consider is that application secrets don't change all that often, so you can leverage caching of your secrets when you fetch them in your applications to reduce the number of API calls to the Secrets Manager service. And now we can finally jump into the AWS console, and I'll show you how to start using the AWS Secrets Manager service. From the AWS console, let's look for secret, and the Secrets Manager service is going to pop up. So let's go into the Secrets Manager, and here you can find some basic info about Secrets Manager. There is also the pricing section here, which covers what I already said. It's 40 cents per secret per month, and then 5 cents for every 10,000 API calls. Now let's click on Store a New Secret, and let's create our first application secret. The first thing you get to pick is the secret type, and you have a few options out of the box. This could be credentials for an Amazon RDS database, credentials for a document DB for Amazon Redshift. It could be credentials for another database, or it could be another type of secret. So that's what I'm going to choose because I'm going to store an API key. Then we get to set the actual value for the secret, and you can choose between a key value format, which is going to be serialized into JSON, and this gives you the ability to store multiple values in one secret, and it's an option to consider if you want to control the price. I'm going to choose the plain text approach, where I'm just going to specify my application secret. I'm going to specify bearer, and then this is my GitHub API key, and this is going to represent my access token, which is going to be the secret value that I will be using. Let's see what else we have here. The next thing is choosing the encryption key, and by default, this is going to use Amazon's key management service to manage encryption, but you can decide to provide your own value. I will not be doing this, so I'm just going to click next. Then we have to name our secret, and I'm going to call it GitHub Access Token. You can provide a description for your secret so that you can easily remember what is the value that you stored inside. We can also add some tags, define a more strict access policy using IAM. I won't be doing any of this, but it's an option, and you can also replicate your secrets in other AWS regions. I won't be doing any of that, so let's just click next. Now here we get to configure secret rotation, and by default this is turned off, but if you turn it on, you can configure what is the schedule for how often you want to rotate your secrets. Let's say we want to rotate the secret every 3 months. This is how we would set this up. And how this works is you need to provide a Lambda function that's going to be invoked when the rotation period expires, and the Lambda function is responsible for returning the new secret value. I won't be needing this for my example, but this is how secret rotation works in practice. So let's click next. We get a review of all of the options that we configured. There's even some code samples so that you can see how to integrate this with various languages. Here is the C# version, which uses the SDK. I'll show you how to do this step by step when we go into the code. For now, let's click store, and this is going to create our secret. If I click refresh, we should be able to see the secret value, and you can also go into the secret where you have a few options. For example, you can retrieve the actual secret value if you want to view it again. You can also decide to edit your secret, which is going to create another version. So that's something interesting that this service allows you to do. If I click on the versions tab, you can see that I have only one version for this secret, which is called AWS Current, and this is the default version. If I were to add more versions, they are going to show up here, and by default, we will be retrieving the latest one. So this is a high-level introduction to the Secrets Manager service. Now let's jump into our .NET application and see how we can use this secret. Let me first walk you through the application that I have here, and it's a simple .NET 8 web API that integrates with the GitHub API to allow us to call some endpoints. The API credentials are managed through the GitHub settings class, which contains the base address, which is a configuration value, and I added it inside of my application settings. Then we have an access token and a user agent, which I stored inside of my user secrets. If I navigate to the user secrets for this web API, here are the secret values. And this is the same key that I specified inside of AWS Secrets Manager, and the user agent is just my GitHub username. So this is how I'm able to provide these secret values securely in my local environment using the user secrets feature. But let's say I want to move this into production, so I want to start using AWS Secrets Manager. We also have an HTTP client, which is the GitHub service. It's configured to call the GitHub API, so we set the base address ahead of time. I also have a delegating handler, which is the GitHub authentication handler, and all it does is set the authorization header and the user agent header using my GitHub settings class. This access token value is coming from my user secrets, and we are going to change this to use AWS Secrets Manager. But before that, let me also show you the API endpoints that I have. We have a get endpoint for fetching a user and a patch endpoint for updating the user's bio. So let me start the application and just show you how this is working. I can send a get request using this endpoint, and I just need to specify a GitHub username. Of course, I'm going to use my own, and we get back the public information for my GitHub profile. The patch endpoint is going to hit this bio here. So I'm going to copy the current value, and I'm going to use that inside of my request body. And here I'm going to specify the value that I copied, and I'm going to update it to, for example, say .NET Tech YouTuber. You'll notice that I'm not specifying my GitHub username, and this is because this endpoint only works for the current user, which is identified through the access token that we are sending to the GitHub API. So if I send this request, we will get back a 204 no content response. And now if I fetch my profile again, you can see that it's updated to say .NET Tech YouTuber. So our API is working. Now let's go back to our code and see how we're going to integrate AWS Secrets Manager. We will want to access our secret inside of my delegating handler, and I'm going to need an additional NuGet package to be able to interact with my AWS service. I'm going to look for Secrets Manager, and the service that I want to install is AWS SDK Secrets Manager. Let's go ahead and install the latest version, and let's go back to the delegating handler. The first thing I need to do is to create an instance of an Amazon Secrets Manager. This is going to be our client, and I'm going to instantiate it using the concrete type, which is the Amazon Secrets Manager client. You will need to be authenticated for this to work, and the simplest approach that you can use is the basic AWS credentials, which allow you to specify an access key and a secret key. If you're using AWS Toolkit for Visual Studio, you probably already have this, but if you don't, you can obtain an access key and a secret key from the AWS console. I already have this set up, so I'm not going to specify this, but I do need to specify a region endpoint. So let's target the region where I define my secret, which is EU West 3. So that's what I'm going to specify here. If you want this value to be configurable, you can provide it from your application settings and call get by system name and provide the region that you want to use, and it's also going to work. But I'm going to specify the concrete region because I already know it ahead of time. The next thing I need to do is to define a get secrets value request, which I'm going to send using my client. So let's instantiate it. And here I need to specify my secret ID. So let me just rename this to secret request to avoid the naming conflict. And the secret ID is GitHub access token. As I said, you can also specify a version if you want to. If we don't specify a version, AWS Secrets Manager is going to return the AWS current version. And this is what I want. So I'm going to omit this, and let's just specify the secret ID. And finally, we're going to get our response, which is going to be a get secret value response. So let's call this the secret response. And we're going to get this using our client, and we're going to call get secret value async. I'm going to specify the secret request, and this is going to give us back our value. And finally, I can use the secret response to obtain the secret string, which I can pass in as my authorization header. So let's quickly test if this is working as expected by running our application. I'm going to send the same API request to fetch my GitHub user profile, and when I send the request, we land in the breakpoint inside of my delegating handler. So I'm able to create my client instance, which means that my authentication is also working as expected. Then I'm going to create my secret request and send it to the AWS Secrets Manager to obtain a secret response. So here is the response that we get back, and you will see that the secret string contains the actual access token value that we can use to authenticate with GitHub. So if I press continue, we'll get a response back in our Swagger UI. So our authentication to the GitHub API is still working as expected, only this time we are obtaining the application secret using AWS Secrets Manager. And this is the standard way how you can interact with this AWS service using the SDK. Now there is another option that allows us to leverage the options pattern that we have in ASP.NET Core, and this is a NuGet package that implements a configuration provider using AWS Secrets Manager. So let me show you how to use this NuGet package as well. We're going to look for a NuGet package, and I will look for Kralizak, and the NuGet package that I want to install is extensions configuration AWS Secrets Manager, which, as I said, provides a configuration provider for the AWS Secrets Manager service. So let's go ahead and install the latest version, and then let me show you how to use this to allow us to continue to use the options pattern while obtaining the secret values from AWS Secrets Manager. So all we have to do is say builder configuration add secrets manager, and this is enough to configure the default settings. You can also define your region ahead of time, so I can specify region endpoint EU West 3. And another thing that this library allows us to do is to configure the Secrets Manager configuration provider options, and let me show you why we might want to do this. If you take a look at the properties that you have on the options object, it allows us to configure some interesting things. For example, we can configure the key generator, we can configure a polling interval if we want to refresh the values at runtime on a given schedule. There is also a filter for the secret values that we fetch from AWS Secrets Manager, and a few other things that you can configure. Now, in order to use this with the options pattern, we will need to follow the naming convention that the options pattern uses. And this is the name of the section, and then the name of the individual properties divided by a colon. So what you can do is provide a function with the key generator property, and this gives us access to a delegate which contains the actual secret entry that we won't need and the secret name that I'm going to use to provide the value that's required for the options pattern to work correctly. So I'm going to say secret name replace, and I'm going to specify 2 underscores, and then I will say that we want to replace this with a colon. And this is going to be my key generator. Now we also have to define a secret in AWS Secrets Manager that's going to follow this naming convention. So let's go back to AWS to add this secret value. So we are back in AWS Secrets Manager, and I'm going to click Store New Secret. I will choose Other, and I'm going to store the same access token in plain text format. Let's click Next. And here I want to spend a moment to discuss a naming convention that you can use for managing your secrets across various environments. If you take a look for the placeholder that we have here for a secret name, it starts with prod, which is short for production, which is actually our environment name. Then we have the application name, app beta, for example, and then the actual secret value, in this case MySQL, which is probably a connection string. So let's adopt this convention, and I'm going to start by creating a secret value for my development environment. This is going to be the first part of my secret name. Then I'm going to specify my application name, which is GitHub API, as the second part, and then I'm going to specify the actual secret value. And the section name that I define in my application settings is GitHub, and then I'm going to specify double underscore followed by the actual name of my secret, which is access token. And this is how you can manage your secret values across different environments. So let's go ahead and click Next. I won't be using secret rotation, so let's click Next and then store the secret value. And I'm going to store another secret right away, and here I'm going to just specify invalid access token as my secret value. You will see why in just a moment. And let's create another secret, this time for the production environment. So our production secret is going to be invalid, which isn't all that important, but it's going to serve us well for the example. So let me create this secret and store it as well. And if I refresh here, I should be able to see both of my secret values present. So there they are. So now let's go back to our application where we need to make a few more changes. The first thing I'm going to do is to define a prefix for the key values for my secrets. So my prefix is going to start with my environment name. So I can access builder environment name. Then I can do the same for my application name by using builder environment application name, and I'm going to specify another slash. So this is my key prefix. Because the prefix is also going to be part of our secret name, we have to replace the key prefix with an empty string so that we are left with a value that matches what we need for our options. And another thing that you can do is set a secrets filter that's going to allow you to filter the secret if they satisfy a given condition. So I can check if the secret name starts with our key prefix. Now, if you watched any other video on this topic and even the official documentation for this NuGet package on GitHub, you will see this example for filtering out your secrets. And I don't think it's a good suggestion to use this because this is going to do filtering after you have already fetched all of the application secrets. This is because of how this library is implemented. It's going to send a list request to AWS Secrets Manager to fetch all of the secrets that you have defined. And then for each individual secret is going to send an additional API request. You can filter out that request using this particular property, which I don't think is a great approach. And a better approach is to simply not fetch the secrets that your application doesn't need. And you can do that by setting the list secrets filters. This is an array where you can define your filter instances, and the filter has a key property where I can specify a filter name string type, and I want to filter based on my secret names. And then for the values, I can specify an array of strings which are going to be my filters, and I just want to specify my key prefix. And this is going to do a prefix match based on this prefix here across the keys that I have defined inside of AWS Secrets Manager, and it's only going to return the values that match this prefix. And doing it like this makes the secret filter redundant because you will already fetch just the keys that this application needs. Additionally, you should set up your access policies in Secrets Manager so that only your application is able to read a given set of secrets. So this is the base setup that we need. I mentioned that we can set the polling interval. For example, you can specify time span from hours, and let's say I want to refresh this every 1 hour. If you want to be able to update your secret values at runtime, this is something that you should consider. Now let's go back to my GitHub authentication handler, and I'm going to comment out the previous request that we were sending using the SDK, and let's just go back to accessing the GitHub settings and using the access token. So let's see if this is working using iOptions and the NuGet package that we installed. I'm going to send an API request to fetch my GitHub profile, and you can see that we land on this breakpoint. And if I take a look at the access token, you can see that the value is present. I can press continue and get a response back in Postman. Now let's stop the application and go into my launch settings. And for the HTTPS profile, which is what I'm running, let's update the ASP.NET Core environment to production, and then let's start the application. And this time around, I'm going to send a batch request to my API, which is going to land on the same breakpoint. And if I take a look at the locals, because IntelliSense isn't cooperating, you will see that the value of the access token is invalid access token, which is the value that we set for our production environment. So I'm going to hit continue, and this is going to fail. You will see that I get back an internal server response. This is because I'm not able to authenticate with the GitHub API because my access token is invalid. So these are your two options when it comes to using AWS Secrets Manager from .NET. You can use the SDK, which is built by AWS, or you can use an open source NuGet package that's going to allow you to use the options pattern together with AWS Secrets Manager. If you are concerned for interacting with Secrets Manager through a third-party NuGet package, you can take a look at the source code for this library and make sure that it's not doing anything shady. And when you find a version that's suitable for you, and if you're not satisfied, you can always fork that repository and customize the application based on your needs. If you want to learn more about AWS, I made an excellent video about implementing messaging using the SQS and SNS services, and I think you should watch this video next. Also, check out my clean architecture and modular monolith courses, and until next time, stay awesome.